Hello everyone, I am Jamshid Ahmadi, a PhD student in geology at Miami University, working under Dr. John Rakwan's supervision. I'm from Iran and always been interested in minerals. When I was in my home country, I would prospect, collect, and sometimes dig for minerals, and the Demantoid was my favorite one. Here I'm going to give you an overview of the mantoids from Iran, particularly from the Belqeys Mountain, and go through some SEM EDS studies that we've done to identify their inclusions. As you know, the Garnet mineral supergroup belongs to the nesosilicates with this general formula in which Z, Y, and X represent sites occupied by cations in coordination 4, 6, and 8. And these are the uh, cations that can sit in those sites. Garnets with calcium in X site uh, for the Ograndite series named for Uarovite, Groslar, and Androided garnets. Uh, Demantoid actually is the green androdite variety of garnet, and traces of chromium substitution in Y site is in control of the deep green color. Demantoids reported from a variety of locations around the world like Italy, Namibia, Iran, Canada, and Pakistan, but Russia and Madagascar are the most important countries producing Jimmy crystals and collector specimens. There are two major localities in Iran in which the mantoid mineralization occurred. The Belqeys Mountain, which is located in West Azerbaijan province that produces collector specimens, and Soğan, which is located in southern Kerman province and produces gemmy crystals. In Soğan, talc is the dominant mineral associating demantoids, and mineralization is hosted with ultramafic rock units. No particular works have been done on the genesis of the deposit, but it is suggested to be skarn mineralization. Just like what we can see in the Belgaes Mountain. The mantoids from this locality are in different sizes from millimeters to a couple of centimeters, but gemmy materials are below 5 carats, and larger gemmy crystals are very rare. There are from light to deep green color, and chromite and magnetite are the most common inclusions. Horsetail inclusions, which may increase the value of those crystals, also can be seen in some cases from the location. The picture on the left shows a demantoid cluster from Soğan, and here's a video of the crystals after cut. Personally, I always get captivated with their dispersion. Okay, let's talk about the mantoids from Belgaes. As I said, they are collector specimens, and gemmy crystals have never been reported from the location. They are desirable for their deep green color, luster, large crystals, and sometimes great contrast within the matrix. Concentric zoning is one of the features that we will talk about it in a little bit. And you can see it here on this broken piece of crystal. Belqeys Mountain is located in West Azerbaijan province, in adjacent of Takht Suleiman village, which is located here. Um, uh, and is about 150 kilometers west of Zanjan city. Here is a picture facing to the north from Takht Suleiman Castle. This is the Belgaes peak. And these are the excavations that have been done to extract the demantoids. Here is a closer look of the Belqeys peak. And these are some of those excavations. Here are two shots of the dug trenches and natives who work to extract the demantoids from the location. Here I've taken and included some photos of specimens from the locality. I'm sorry, I know they're not the best photos. Mineralization occurs in both fractures and pocket morphologies. Here is another photo. There are large lustrous crystals dominated by trapezoidal and dodecahedral faces on a matrix of marble. In this photo, the demantoids are associated with calcite and diopside. And here's another one with a lot of crystals on it. Okay, Belgaes Demantoid deposit is suggested to be kind of a skarn deposit. Skarn deposits are formed as a result of replacement, alteration, and contact metasomatism of the surrounding country rocks by ore-bearing hydrothermal solution in vicinity of a mafic, ultramafic, felsic, or granitic intrusive body. They are usually associated with calc-silicate minerals like garnet and pyroxene, just like what we can see in the region. This is a geological map of the region, and Belqeys Demantoid deposits are located here. In the limestone interlayers within metamorphosed Paleozoic amphibolite and ophiolitic rocks like serpentinite and basalt. An intrusion with granodiorite composition is believed that affected the area during Jurassic and is considered as the source of hydrothermal fluids for skarn mineralization within these geological units. The granodiorite intrusion has a vast occurrence here in the eastern part of the region. There are also several economic iron skarn deposits which are getting mined in the area, possibly formed during this process. To investigate the associated minerals, inclusions, and chemistry of concentric zonings, we use scanning electron microscopy coupled with energy dispersive spectroscopy after taking thin sections and carbon coating. Here is a backscatter electron image of inclusions that shows the relative difference in atomic number of constituents. I personally love this image because it's like a tree. This image is captured under a 25 kV, 120 micrometer of aperture and 10 millimeters of working distance. The tree is composed of mostly diopside and quartz. There are also small inclusions of hematite, chromite, and pyrites. Embedding crystal is a demantoid which shows zoning in these regions. Images on the right shows the EDS spectrums of demantoid and diopside with iron, chromium, silica, aluminum, and calcium for demantoid, and silica, calcium, and magnesium for diopside. In a closer look, this image shows intergrowths of demantoid, diopside, pyrite, hematite, and on the right you can see the EDS spectrums of pyrite and hematite with sulfur and iron peaks for pyrite and oxygen and iron peaks for hematite. Here's another backscatter image of intergrowth of demantoid, quartz, and hematite with chromite inclusions in quartz. And on the right you can see EDS spectrums of quartz and chromite. And finally, here are two high magnitude BSC images of chromite and magnetite, showing their euhedral morphology despite their sizes of few microns. Last slide is showing the concentration of some major elements possibly contributing in the demantoid crystal structure and their behavior along different concentric zones within crystal growth. Iron shows a slight increase of concentration in light regions. Chromium shows the same feature but with more differences in concentration from 0.1 to 0.8%. Aluminum concentration, on the other hand, is tied to dark regions within over 7% changes. Calcium concentration decreases in dark regions. Titanium and magnesium concentrations decrease within crystal growth gradually and show a slight increase in dark regions. Silica shows a similar feature as for chromium and iron, and its concentration rises in light regions. Thank you for your attention, and I would be happy to answer to any questions you might have.